Okay, this is the last of the new lessons for Unit 12. This is Unit 12, Day 8, more trig applications. Number 1, the height of the blade of a wind turbine as it turns through an angle of theta is given by the function you see there, with the height measured in meters. Find the maximum and minimum positions of the blade. So we have a wind turbine. I can't draw, but there's my blades. Okay. And we said in the other lesson that the center of whatever circular object you're talking about is your midline. So that means the center of that wind turbine is 40 meters in the air. Your maximum position, which would be the end of the blade sticking straight up, would be whatever that midline is plus your amplitude, and that would be 8.5. So your maximum position of the blade would be 48.5 feet in the air, and then if you subtract your amplitude, 31.5 feet would be the lowest that the blade would hit. Okay, so the tip of this blade goes between 31.5 feet and 48.5 feet in the air. Explain what the 40 in the equation represents. We kind of just did. It is the center of the turbine, or it's the height of the center of the turbine. Explain what the value of the amplitude represents. Now, generically speaking, amplitude is how high above the center your graph goes. Well, in this case, our turbine has blades on it. So if you think about it, if my blade is sticking straight up, then the tip of that blade is at 48.5, which basically means the amplitude is telling me how long the blade is. So the 8.5 feet is the length of the blade. Number 2. Population of prey in a predator-prey relation is shown time and year since 1985. Determine the maximum values of the population to the nearest 50. Use these values to find the amplitude and the vertical shift. So it's kind of hard to see, but your graph starts right here. Here's your highest, and I'm going to say that's about 850. And here's your lowest, and I'm going to say that's about 250. So if we got to find our midline, which would be right here, 850 plus 250 divided by 2 will give us 550. And that's hard to see, but that's where that graph starts. So your midline is 550. So use these to find the amplitude. Well, if your midline is 550, you have to go up 300 to get to the 850. The vertical shift is your midline, so that's 550. Write the equation of the function. Alright, so we needed the amplitude, the midline, we got both of those. Now we just need the frequency. So period equals 2 pi divided by frequency. One full cycle, it's a sine curve, so we go up the hill, down the trough, and it ends right here, which looks like 6 seconds. So the period is 6. Cross multiply, 6f equals 2 pi, divide by 6, f equals pi thirds. So there's our frequency. So our equation is y equals amplitude 300 sine frequency with an x plus the vertical shift. Number 3. An average seated adult breathes in and out every 4 seconds. Breathing in and out is a cycle, so the 4 seconds must be our period. The average minimum amount of air in the lungs is 0.08. The average maximum is 0.82 liters. Suppose the lungs have a minimum amount of air at time 0, where t is the time in seconds. Write a sine function. Alright, so we know it's sine, and it should kind of make sense anyway, because you're going to breathe in and out. So actually, I'm not going to put this on coordinates. You're going to breathe in, then you're going to breathe out, and you're going to come back. Now, it said the minimum amount of air in the lungs is 0.08 liters. The maximum is 0.82 liters. So from that, I need to find my midline, which is the average of the two. 0.82 plus 0.08 divided by 2. 0.9 divided by 2 is 0.45. So my midline is 0.85. Amplitude then is how high above the midline I go. So if I take 0.82 and subtract the 0.45, then my amplitude is 0.37. So I have my midline, I have my amplitude, I need my frequency. Period equals 2 pi divided by frequency. We said the period was 4 seconds. Cross multiply. My frequency is pi halves. So we've got y equals amplitude 0.37 sine frequency x plus the midline. And there's our equation. A tsunami is a fast-moving ocean wave caused by underwater earthquake. The water first goes down from its normal level, then rises an equal distance above normal level, then finally returns to normal level. The period's about 15 minutes. Suppose that a tsunami with an amplitude of 10 meters approaches the pier in Honolulu, where the normal depth is 9 meters. So here was normal depth, that's 9. If the amplitude is 10, then if I go 10 down, that puts me at -1. If I go 10 up, that puts me at 19. Now obviously that's a sine curve because it's got the trough and the hill. Alright, so amplitude was 10, they gave us that. Midline is going to be the normal depth of the water, which is 9. I just need a frequency. So period said takes 15 minutes. Equals 2 pi divided by frequency. Cross multiply. Frequency equals 2 pi divided by 15. Alright, so our sine function, it went down first, so negative. Amplitude was 10. Sine frequency x plus midline. By the way, if you're concerned about the fact that there's a -1 here when we're talking about water, usually the water is 9 feet deep. -1 kind of means the water goes underground. I don't know if you've ever watched the video of a tsunami. You should pull one up, but at some point the water gets pulled way back, which means you might not find water for a foot under the surface of the sand. So it is okay to have that as a -1. That just means the water has been drained and you won't find any for at least a foot into the sand. Alright, good luck writing your equations. This is the end of the unit. The next video will be the answers to Day 9 review. Day 9 review, I believe, is all Regents questions.